Hello students, now we are going to discuss an important concept in C++ language, the structures. Structures also exist in C language and the structures have formed the basis for the concept of classes. Okay, so understanding the concept of structures will help us to build the foundation for the concept of classes. Okay, so what is a structure? A structure is a collection of simple variables. You can say that array is also a collection of variables. Then what is the difference between a structure and an array? An array, yes, it is a collection of variables, but in array, all the variables are of same type. So you can say that all the variables are homogeneous. An array can be of all ints and array can be of all floats. Okay, but structure, it can have heterogeneous types of variables. Okay, structures members can be heterogeneous. For example, a structure can contain an integer, a float and a character. Okay, so this is the basic difference between an array and a structure. So some variables can be int, others can be float. And these data items or the members, these data items in a structure are called the members of the structure. Okay, so this structure has one integer member, one float member and one character member, right? So now here we look at an example of a structure. So in this example, you will know how to create a structure, how to declare a structure and how to create the instances or variables of that structure, how to access the variables in a structure. So all these things will be known to you after discussion of this example. Okay. So the first thing here is the keyword struct. So if you want to create, if you want to declare a structure, you have to first write the keyword struct. It tells the compiler that we are going to declare a structure. And then part. Part is the name of the structure. Okay. So you can have any name, any valid identifier is allowed here. Okay. So here we name this declaration part. Okay. And then you can mention the members of this struct part and the members are mentioned inside these curly braces. Okay. So it has three members. Int model number. Okay, so this is the first member which is an integer. Int part number, this is another integer member, and float cost. This is the third member which is of type float. And remember that the structure declaration ends with a semicolon. So after the closing brace, you have to put the semicolon. So this declares a structure. Okay. Then inside the main, what are we going to do? We are going to create the variables of the structure. So this is just a declaration. Declaration means no memory is allocated to this structure. Okay. So this does not occupy any memory. This is just telling the compiler that we are going to use such type of structure in this program in future. Okay. So this is just telling the compiler that we are going to create such type of a structure. We are not allocating memory here. This is just declaration, is just telling. Okay. So when is memory allocated? Memory is allocated when you create the variables of that structure. Just like you write int a, what are you doing here? You are creating the variables of type integer. Okay. So when you create the variables of type integer, memory is allocated to the variables. So when you write this statement, memory is allocated equal to the size of an integer. For example, if integer is of 2 bytes, then 2 bytes memory will be allocated. Okay, so this is definition. We are actually allocating the memory to the variables. We are creating the variables in the memory. Okay, similarly here also we are creating the structure variable. So in order to create the structure variable, what we need? We need the type of the structure. What type of structure you are going to create? We are going to create structure of type part. Okay, and then next is the variable name. What is the name of this variable? Name of this variable is part1. Okay, so we are creating the struct variable just like we are creating the integer variables. Okay, so this is also called part1, is also called instance of type struct part. Just like A is an instance of type int, similarly part1 is an instance of type struct part. Okay, and another way of creating the variable is you can write the keyword struct, then part, then the variable name part1. Okay, but this is also valid. This is not necessary. Okay, writing the keyword struct when you are creating a variable of type struct is not necessary. Okay, this is optional. This is sufficient. Just write the part, write the name of the structure declaration and then write the name of the variable which you are going to create. Okay, so what happens with this statement? With this statement, memory will be allocated. Okay, so how much memory will be allocated? Equal to the enough memory will be allocated so that we can accommodate all the members of this structure. Okay, so if integer occupies 2 bytes, so we need total 2 plus 2 plus, suppose float occupies 4 bytes, then total 8 bytes memory will be occupied. 2 bytes for integer model number, then 2 bytes for part number and 4 bytes for cost. So this much memory will be allocated and we can access this memory using this variable name part1. Just like when we are creating the memory, when we are creating an integer, we can access that integer using the integer name. Here we can access this memory using a. If we write a equal to 10 in our program, then the value stored at this memory location will be equal to 10. Similarly, using the name part1, we can access this block of memory, right? So how to access each data member using this variable name? The syntax for accessing the members of a structure is the structure with a struct variable name dot and then the member name. Okay, here we are accessing part1 dot model number. So through part1 we are accessing the member model number and we are assigning it a value 6244. Okay, so 6244 will be stored at the location of model number. Okay, similarly part1 dot part number. So through structure variable part1 we are accessing the member part number and we are setting its value equal to 373, right? Part1 dot cost 217.55, right? So using this dot operator, this is also called the member access operator. Okay, this dot operator is also called member access operator because through the dot operator we are able to access the members of a structure. Okay, Similarly, how to display the structure members? Cout model. Model is equal to part1 dot model number. Then part is equal to part1 dot part number. Then cost part1 dot cost. Right? So before moving forward, let us execute this program. So let me copy this. Let me include the necessary header files and namespaces. Okay. Now this is the structure declaration here. In the main program, we are creating the structure variable. Then we are putting the value inside that structure variable using the dot operator, and then we are displaying those values using the same format, the structure variable, dot operator and the member. Right? Let's run this program. Struct.cpp, let's name it. I think there must be an error because of these parentheses. Let me correct this. Okay, we are good to go. Okay, so now we are able to display the values of structure variables, structure members, model number, part number and cost, right? Let's get back to the PPT. Okay, moving forward. So these slides recap the concepts which we learned in the previous example. That is how to define a structure. Structure definition tells us how the structure is organized, what members are there in the structure. Okay, so the definition of the structure contains the keyword struct, then the name of the structure. This is also called the struct tag. Okay, tag of the structure. And these braces delimit the members of the structure. So there are 3 members, and remember that you have to end the definition of the structure with a semicolon, right? So this structure definition, as I told you, this is only a blueprint for the creation of variables of type part. Blueprint means it tells the compiler that if you declare a variable of type part, what it will look like, what the members of this variable part will be. Okay, so it does not create any variables, that is, it does not allocate any memory. Okay, so how the structure variable is then created? Using this syntax, the name of the structure and then the name of the variable. Okay, so when you do this, then memory will be allocated equal to the size of the structure. Okay, so here for example 2 bytes are reserved for int model number, 2 bytes for int part number and 4 bytes for float cost, right? So you can create as many structure variables of same struct as you want. Okay, for example, here we have the structure definition for hypothetical struct whose name is foo. Okay, there is a struct foo. We have defined structure of this name. Okay, then what the structure definition tells us? It tells us the specifications, means what will be the members inside this structure foo. Okay, then you can create any number of variables of this struct foo. For example, here we are creating foo1, then foo2, then foo3. Okay, just this is very similar to the concept of creating the multiple members of same data type. Okay, they look alike. Okay, so how many variables you are creating of any struct type, that much memory will be allocated. Okay, suppose for the struct part you are creating three variables, part1 comma part2 comma part3, then memory will be allocated for three structures. Okay, so this is the memory of part1, which contains memory for model number, memory for part number, and memory for cost. Similarly, memory is allocated for part 2 and memory is allocated for part 3, right? So, in the last example, we initialized the structure variables by writing the variable name, for example part1, then dot model number. Okay, then we assign it a value, something. Similarly, we did the same thing for other members, part1 dot cost equal to something. Okay, but there is another way of initializing the structure members. So here we have the same structure, struct part, int model number, int part number, and float cost. But here we are initializing the members of the structure using this list. Okay, so part1, what are we doing here? We are creating a variable of struct part whose name is part1, and this equal to operator contains a list of the values on the other side. Okay, so these values are delimited by the opening and closing curly braces. So the first value refers to the first member, that is first value is for the model number, second value is for the part number, and the third value is for the cost. Okay, so this is another way of initializing the structure members. Okay, and here we are creating another structure variable part2. Okay, but for part2 what are we doing? Let us first examine what this statement is doing. Here we have already assigned the values to part1, then we are displaying those values. So we are displaying the model number of part1, part number of part1, and cost of part1. And in the next statement, what are we doing? We are assigning first variable to the second. Okay, can we do this? Yes, of course we can do this. So here part2 is equal to part1. We can do this only when the type of the structure is same. Here type of variable part2 is part, and also the type of variable part is also part. Okay, so the type of both part1 and part2 is same. So it is possible to assign the variable of the same type to another variable of the same type. Okay, so now part1 and part2 are same. Okay, so you can use part2 dot model number, part2 dot part number, and part2 dot cost to display the same values. Okay, which we assign to part1. Okay, so now let us modify the program we wrote to incorporate these changes. Okay, let's get back to code blocks. Okay, so part1, is equal to, now we use the comma separated list for initializing these values delimited by curly braces. 217.55. Okay, so we have initialized part 1, then we declare part 2. Okay, then we are displaying part 1 members, then we assign part 2 is equal to part 1. Now we are displaying the values of these variables. Part 2 dot model number, part 2 dot part number, part 2 dot cost. Okay, so let's run it. So both are referring to the same part, same structure, so they are displaying us the same values. Okay. Okay, moving forward. So what we did in the previous example, we assigned structure variables to one another. Okay, so one structure variable can be assigned to another only when they are of same struct type, as we examined in the example. Both the part 1 and part 2 are of the same type. What is their type? Their type is part. Okay, or we can say that their type is struct part, to be very concise. Okay, if you try to assign a variable of one struct type to a variable of another, then of course the compiler will give you an error. Okay, so the next is array of structures. Can you create instead of creating 3 variables, part 1, part 2, part 3, if you need to create 10 such variables, then will you write such comma separated list? No, we do not need to do this. The solution to this is we can create an array of structures. Okay, so define a structure just like we defined part, struct part. Okay, define its members and then declare an array variable of that type. How to declare an array? The type is part and the array can be declared using the subscript. Okay, and in this subscript mention the we have to give this array a name also. Okay, so the type is part and the name of the array suppose is parts, and then how many parts you are going to declare? Suppose 10 parts. So in the square brackets in the array subscript mention the size of this array. Okay, so it will create 10 such struct parts. Okay, so here is another example. If you have created a struct of type address, okay, then you are creating this is actually one line. Okay, as I told you, you can write the keyword struct here or you can omit it. Okay, this is not compulsory. Then ADDR, what is this? This is the type of the structure. Okay, just like part is the type of the structure. And then what is this? This is the array name. And in this square brackets, you are telling how many such structures you are going to create. So here in this case, we are going to create 100 such structures, right? So the next question is how to access a specific structure. So if you want to access the second structure, the structures start at the array of structures just like the array of integers start at index 0. So 0, 1, 2. So if you want to access the second structure, that is this structure, then how will you access it? Write the name of the array and then write the index. Okay. So cout address info 2 dot zip. The member which we are going to access is zip. Okay. Like all array of variables, array of structures begin at indexing 0.